All right, so today's topic is geometry. Okay, so we change the topic every time. This is comprehensive math class. So the homework problems will be the previous math counts. Okay. So today we're going to focus on geometry. And I want to talk about area comparison. Area comparison among the triangles. Now, suppose you have two triangles. There are two type of a comparison theorem. Okay, so you have A and B and C. Another triangle, it's not similar. Okay, so another triangle maybe looks like a very, looks like that. Okay, so it's A prime, B prime, C prime. So the question is if they have the same height. Okay, that's the first comparison. Then the ratio of the area A, B, C, and another one, A prime, B prime, C prime, is going to be the ratio of the base. Okay, you know why? Because because the height in the formula, the formula is that says half of, right? Half of the height, right? The height is h, then BC, right? And BC is the base. So the height is the same. So the actual denominator and numerator, they both have the same h that be canceled out. Okay. The second, so they're very useful. This is very useful when you compare the area of two triangles. Okay, you just needed to compare the two bases. The second one is if the two triangles have the same angle. Okay, if here's A, B, and C, and A prime, B prime, C prime, then the ratio of the area, I'm going to use here for simplicity. So use X and the Y, X prime and Y prime. Okay, so the area of the triangle ABC over the area of the triangle A prime, B prime, C prime is just going to be X times Y over X prime, Y prime. Okay, so if they have the same angle. Okay, one more comparison. So this is a two triangle. Now this time the two triangles are similar. Okay, they're similar. A, B, C, and similar means here's alpha. Then this is a alpha. That's a beta. That's also alpha. That's a beta. Okay, and that's gamma, and that's gamma. So if we have A prime, B prime, C prime, these two triangles similar. Okay. Then the ratio of the area will be, you just need the one side. Okay, if this side is A, this side is A prime, then the ratio of the area A, B, C, A prime, B prime, C prime is just equal to A over A prime and the square. Okay, so if the ratio, if 1 to 5, then 1 over 5 square will be 1 over 25. So the other triangles, the larger triangle will contains 25 small triangles. Okay, so those are the three important comparisons here for the area. Okay, so now let's take a look at the problem. Okay, we have a triangle. It's not necessarily equilateral triangle, right? So it's A, B, and C. Okay. So P is P is here. Okay, this is a problem from the first homework actually. And we'll do step by step. And Q is here. Okay. So now you draw the line. Okay. We are given the following information. Okay. We are given the following information. If AP over AB equals AQ over AC equals 1 over 5. Okay. Then you will see that I think these two triangles will be similar. Okay, so these two triangles then will be similar. It's easy to see that to triangle APQ is similar to triangle ABC, okay? So using similarity, okay? So if you compare the areas, okay? If you know this area, I'm going to call it AP. Yeah, this I'm going to call the Y, okay? Y is going to be the area. Y is going to be the area of the triangle APQ. Okay. Then the area of the larger triangle ABC, right, is going to be what? Is going to be 5 square times the area of the triangle APQ. Okay, you know why? Because the area of APQ over the area, you know, the ratio of them, right? If we divide this to this side, that'd be the ratio of their side, the square. The ratio of the side would be 5 because AB to AQ, AP is going to be 5 to 1. Right, so that's why actually you have a 25 times the area of the small. So this larger triangle is about 20, yeah, it's 25 times the area of the large triangle is 25 times the area of the small triangle. Okay, so if this is a y, then that's just 25y. Okay, that's the first thing to do. Okay, so now we continue. Okay, so here's a P, Q, A, B, C. So this time I'll draw the lines, and this R. Okay. Now, since these two triangles are similar, okay, and we still have a, you know, AP over AB equals AQ equals AC, right? Actually, because similar, it's actually is a PQ over BC is equal 105. Okay, they're all the same. All right, so PQ over BC is going to be 105. So now let's compare those two triangles. Let's compare those two triangles. One is this. One is this. What's the relationship? Those two triangles are similar. Okay, those two triangles are similar. The triangle PQR, because this angle equals that angle, alpha, alpha, beta, beta, gamma, right? So similar, PQR is going to be the triangle CBR, okay? C corresponds P. So now, since PQ over BC is going to be 105, so the triangle at the bottom, the larger triangle, is going to be 25 times, the area is going to be 25 times the area of the small triangle. Okay. So what I'm going to do, I have to call it X, maybe, right? So, so I'm going to let the area of the triangle PQR to be X, okay? Then the area of the triangle PQCBR, okay, the larger one, is going to be what? It's going to be it's going to be 5 square again, times area of the small triangle, compared with the small triangle PQR. Okay. Okay, so that is going to be 25x actually, because BC is 5 times PQ. So that's going to be 25x. All right. Wow. So we get some kind of, you know, step by step, right? Let's go back to this triangle again. What we can do? So A, B, C, P, and Q. Okay, that's R. So we know if this area is X, this will be 25x, okay? The area of this part I think if this is a y, right? So area of this part will be 25y minus the y, actually is 24y. You know why? Because the area of the larger triangle is going to be 25y. So you have to subtract the small one. So this whole portion is 24y. And now you have we just don't know what is this part, right? Okay. Then think about that. Okay, I'm going to paint this triangle. Okay, clear, no problem. I'm going to paint this triangle. What's the relationship between those two triangles? The area. Can you tell that? All right, these two triangles have the same height. So the ratio of these two sides is 1:4. Okay, because we said, remember, AQ to AC is going to be 1/5. So that's why AQ to QC is going to be 1/4. Okay, right? Okay, that's what we needed to compare the area of two triangles. So the area of this triangle, CPQ, okay, the yellow one, should be 4 times area of the triangle APQ, okay? So it's going to be 4y. Okay. This part is the yellow one is 4y. And by the same reason, okay, similarly, this part is also 4y, the other side. The area of the triangle, yeah, so let's look at these two triangles. Okay, those two triangles. It's also 4y. Okay, the triangle PQB is going to be 4 times the area of triangle APQ. So it's a 4y, okay? All right, but so now I'm going to add all the pieces together. Okay. So this part is the yellow part, this part, each triangle here, right? It's a 4y minus x because there's x here already subtract. This side is also 4y minus x. Right? Now each triangle y, x, 4y minus x, and 525x. Right? But they're all added together should be equal to 24y. So let's look at the bottom part, okay? X plus 4y minus x plus 4y minus x plus 25x. That should be equal to 24y. Okay. So that's the equation gives you the relationship between x and y, because then you can determine, you can tell everything. So once x is figured out, then you get all the pieces here, all the small triangles area. Okay, so let's see, what do we get? XX, okay, here's 8y plus 24x equals 24y. Okay, so that means 24x equals 16y, right? That means x over y is going to be 16 over 24. It's going to be 2 over 3. Okay, so the relation between x and y is 2 over 3. Okay, 2 over 3. So now I'm going to express the triangle every pieces here. Okay, so there are so many triangles, 1, 2, 3, 4, 5, right? I call this one x. How about this? Then the y is going to be, that's going to be 3 over 2x, right? Everything should be expressed in terms of x. Here's a 25x, right? Yeah, and then 4y minus x is going to be 4y minus x is 4 times. Y is going to be 3 over 2 x minus x. Okay, so let's calculate what is that. I think 6 minus x is 5x. So this will also be 5x similarly. So it's interesting. Now you completely determine the picture. Okay, here's A, PQ, and BC. So if AP over AB equals AQ over AC equals 1 over 5, then if this area is called X, then here 3 over 2x, here's a 5x, and this is going to be 25x. Wow. So each of the triangle here, yeah, so you can do each triangle here, the area is determined by x. Okay, this is a little bit complicated. You can go through, you can try and figure it out by yourself, but trying to express everything, every triangle. Okay, area of every triangle, each triangle in terms of area of this triangle. Okay, that's the whole idea, right? So now let's do the comparison. The comparison PQR over the area of the triangle ABC. Okay, let's count. That's x, right? Okay. Then you have a 3 over 2x plus how many x here? 1x, 11, right? X plus 5x plus 5x plus 25x. Wow. X eventually is be canceled out. Okay. So you will get 1 over 3 over 2 plus how many number here? 11 plus 11 plus 25 will be 36x. Okay, so this x is gone. Let's try, and then that will be 75 divided by 2. So it's 2 over 75. So that is answer in the book. In the answer key. It's pretty long problem. Okay. But once you determine each region, each triangle's area in terms of the area in the yellow color, then you can answer any questions about the comparison of the areas. So for this problem, we use the many, use all the 3 comparison theorems. Okay. I spent too much time on this problem. I'm going to talk about similarity again. Okay. So I have a circle inside, and I draw 2 lines. Okay. Okay. At the very beginning, this is A, C, P, B. Okay. A, B, C, D, right? D. Okay. So we are given some information. We're given information AP is going to be 3. And BP is going to be 4. PD this is a P, okay? PD is a 5. So we want to find the CP. What is that? Okay. And some students say, well, maybe 6. No, actually it's not, right? So look at these 2 triangles. Okay, those two triangles you get here, they are actually similar, but you have to prove it. Why it's similar? Okay, can you see that? The similar, you have to get the corresponding angles, right? It's the same. So these two angles definitely same, alpha, alpha, right? Now I claim that this angle is better than that angle is also better. The reason that both are better is because they have the same foot points. Okay. So because they all come from A and D, just location different, right? So that's why it's so better as same. Okay. So that was B corresponds to C. So the triangle ACP is similar to the triangle DBP. Okay. So once that's similar, okay, when they're similar, I think a PC corresponds to PB. Okay. So PC of a PB, and that should be equal to AP and PD. Okay, so we already PCs, we don't know PC, but we already know PB. That is 4. Then AP is going to be 3. PD is going to be 5. Okay, so PC is going to be 3/5 times 4 is 12/5. Okay, so you have to use the similarity. Now, the most important property using here, I just have here. If you have 2 points fixed, A and B, here's another point. It doesn't matter where we draw the pictures, this angle is always the same. Okay, so it's independent of the location of the point P on the circle. Okay, this is the important property we used here. Right, so the second problem I want to discuss is still similar, but it's from today, from the last homework. Okay, this is circle, right? So here, let's draw 2 lines. A, D, E, B, and C. So AD equals AE. So AD equals AE equals 3. And ED equals 4. Right? And then BC equals 5. We want to find out the area of the triangle BCE. BCE. That is it. Oops. Hold on. Okay. So we want to we want to find the area of this part. Now, how do you find the area of this? Well, you first of all, you look at this triangle. You look at this triangle. Can we find the area of this triangle? The answer is yes. Okay. Then these two triangles are similar. So by similarity, you can get the areas as a triangle. Okay. So how do you find the area of this triangle in the yellow color? So this is the area. This is a triangle like that, right? So A, D, and E. AD is a 3. AE is a 3. And the ED is a 4. Now, can you find the area of this triangle? Well, this is an isosceles triangle, right? To find the area, you just need to find the height. The height is going to be, by the Pythagorean theory, is going to be 3 square minus 2 square root, right? So it's 9 minus 4, so it's 6 square 5. All right, so the area of this triangle ADE is going to be half of the base times the height. So it's 2 square 5. Okay, so you get the area as a yellow triangle. Now, can you get the area as a larger triangle, as a triangle? Well, you have to say these two triangles are similar. The reason is this alpha, then that would be alpha, right? Okay, the angle would be alpha. If this is a beta, that angle is beta. So these two triangles are similar. So the triangle BCE is similar to the triangle and DAE, okay? So if the two triangles are similar, then, yeah, let's put a mark here. It's going to be AE is going to be 3. ED is going to be 4. BC is going to be 5, right? So AD is going to be 3. So the ratio, the corresponds, AD corresponds to CB, okay? Okay, so the area of the comparison, BCE over the area triangle DAE, and that is going to be the ratio of the sides square of the ratio of the sides square. So that should be equal to, we're talking BCE. So that should be equal to BC over DA. And that should be square. Okay. And the BC over BA, BC is already AD, yeah, BC is 5, AD is 3. So 5 over 3 squared. So now you can get the area of the larger triangle. Okay, because it's a 5 over 3 square, and this area we already did. Okay, ADE is going to be 2 square 5. Okay, it's 25 to 9, 2 square 5. And you can say 50 over square 5, 50 over 9. Yeah, so it's going to be 50 over 9 square 5. Okay, so here let's summarize what we used. We use the similarity of the triangles inside the red, inside of the circle. Okay. Then we use the similarity. First of all, we determine the area of the triangle of the one triangle, right? Smaller one. Then use the similarity, you get the area of the other triangle. Okay, so we get the area of the yellow triangle. This is. Okay, so we have in geometry, we use a similarity many times. Okay, for example, yeah, if we have a triangle like that, you have an A, B, and C. So this triangle has 3 sides, 33, 44, and 55. All right, so this divide opposite side into two segments. Divide the opposite side. Okay. So a line bisecting the larger acute angle in a triangle with the sides of lengths 33, 44, and 55 divides the opposite side into two segments. Okay, so that's M. M. Now, what is the length of the short segment of the side? So what do we want to find out? We want to find out this one, right? What is X? Or what? Okay, so first of all, look at this, look at all the three sides. So 33 square plus 44 square equals 50 square. So it is a right triangle. Right. So what can you work out? All right. So this is a bisect, right? Alpha alpha. So our idea is as follows. I draw a addition line. First of all, this is a right angle. Okay, you can verify by the Pythagorean theory. So we draw another line. So you will see these two triangles are congruent. This two triangle ABM is congruent. Let's call it N. Okay, the triangle ABM. So that'll be NBM. Okay, so they are congruent, actually, congruent. Okay, so congruent means this side will be 33, right? Why is it congruent? They both are right triangles and they share one side. Okay, then this side will be X. So then this side will be 55 minus 33, so it'll be 22. How about this side? This side is 44 minus X. Now you have a right triangle, right? This is a right triangle. Right. Can you apply the Pythagorean theory to that? The answer is yes. X squared plus 22 squared equals 44 minus X squared. Right. So you have to express every side in terms of X. Okay. Then you solve this equation for X, then you get the answer. Okay, let's find out. It's 22 square equals 44 square minus 2 times 44. It's 88 square plus x squared. X squared is gone. So 88 x is going to be 44 square minus 22 square. So that is going to be, that's going to be, you can simplify it, right? So x is going to be 44 square minus 20 square, 88. And then you simplify it. That's it. So to this point, it's the rest of them is simple. Okay. So 44 is going to be, that's 11, right? So take 11 square out. Okay, so that's always 4 square minus 2 square. And here's 11 times 8. Okay, that'll be 11. 16 minus 4 divided by 8. Okay, so it's 12 divided by 8. It's a 3 and a 2. 33 and divided by 2. Okay, so that the remaining part is easy. No. All right, so we go back to this problem. You have to, in geometry, you have to draw a addition line. Yes, the line bisects the angle B, and B is given, right? But you needed to draw addition line in order to solve this problem. So in geometry, sometimes you have to draw addition lines. Okay. So this is those are the problems, right? From the previous homework. All right, let me test you to see if you're able to find the area of the triangle. We're talking about triangle. There are many. Okay. Yeah. So we have this triangle here. Okay. So here's a 3, here's a 4, here's a 5. Okay. Then I have a circle inscribed in this. Okay. I'm going to find the radius. Okay. Yeah, please think about it. I'll give you the chance to look at the problem. Okay. Anyone has answers? So a circle with radius size is inscribed in this triangle. Now, first of all, you should notice that this is the right triangle. Okay, this is the right triangle. Okay, 3 square plus 4 square equals 5 square. Right triangle. Okay. Now, how do you find the radius? Okay, for this particular problem, maybe we have a couple ways to solve the problem. Okay, you can try connect this and try this. Okay, so 6 over 5. All right, so we can, the best way I wish to do is, because that works for arbitrary triangle, is going to be, I draw 3 triangles, okay, from the center of the circle. Now, the area of the larger triangle is going to be the area of the sum of the areas of the 3 triangles. So first of all, the area of the triangle is the larger triangle, okay? That is going to be 3 times 4 divided by 2, okay? Now, this should be the area of the 3 triangles. So the first one is 4 times r is the height, then 5 times r divided by 2, then 3 times r divided by 2. Okay, so immediately you will get, now 2 to cancel out. I think it's 12 equals 4r plus 5r plus 3r. Right? That's 12r. So the answer is I is going to be what? All right, so I is perfect number. Okay, it's just integer. All right, so now let's take a look at the next one. If you generalize a little bit, okay, so I'm going to look at this problem here. So I have a triangle, 15, 41, 52. Okay, I want to, first of all, find the area. Second, if I put the ball inside, find the radius, find the radius of the ball, of the sphere, yeah. So this is an, this pretty general triangle. Okay, how do you find there's 3 different ways to solve this problem. Okay. The quickest way to do, okay, if you're lucky enough, okay, if you memorize the stuff, 5, 15, 41, 52. We know that 9 squared plus 12 squared equals 15 squared. And 9 squared plus 40 squared equals 41 squared. Okay, so if you know that, then possibly this side is going to be 9, right? And here's 12. Here's 40, okay? So 12 plus 40 is 52. Then it matches with the Pythagorean, right? 9 squared plus 12 squared is equal to 15 squared. 9 squared plus 40 squared is 41 squared. So if you notice that, then it's easy. So the area is going to be half of 52 times 9. Okay. And that is going to be 234. You can also apply the Pythagorean theory to get the height. Okay. Yeah, you think about it as a method. We also have the so-called the Heron's formula. Okay, we can find the area using Heron's formula. Okay. You can try, okay? What is so-called Heron's formula? Heron's formula, I guess give you a formula, okay? You can plug them into the formula you can get. So the area is going to be, square root of s, s minus a, s minus b, s minus c. Now what is s? S is going to be half of the parameter. Okay. So now let's work on how to find the inscribed sphere. Okay, if this is 15, it's 41 and 52. Okay, it's the same idea because from the center to the tangent point, they're all perpendicular. Okay, then you have three triangles. Okay, let me draw the three triangles. Okay. So the area of the triangle is going to be, we already find out, right? 234. Okay, this also gives the area of each triangle. Okay, like a 52 times r is the height, and plus half of 41 times r, plus half of 15 times r. So it's going to be half of 52, 41 plus 115. Okay. So add them together, you will get yeah, 52 plus 41 plus 15. Okay. It's 108 divided by 2. So I is going to be 2 times this divided by 8. Okay, so probably it's let's see, what do we get? 234 divided by 108. Now, it's about estimate 4.33. All right, so you can simplify the fraction if you want. So this is about the triangles, and now if possible, you can derive the formula, Heron's formula. Okay, that's fine. So next, I'm going to discuss a 3D problem. Right. So this is a rectangular, yeah. So this is a rectangular prism. So here's A, B, E, and F, G, H, D, and C. Okay. I'm going to connect. Yeah, so first I'll give AB equals 8, AB equals 12, BC equals 8. So that is height, okay? AE equals 6. Where's AE? Okay, this is AE, yeah. So this is a 6. AB is 12. And A is 12, right? BC, okay, AB, yeah, BC is height. BC is 8. So the volume of this box is easy to figure out, right? Now what we want to do is the tetrahedron. So we will connect these two. Right? Find the volume of the tetrahedron. D, H, B, C. Okay, so let me color it, otherwise it's hard to visualize. So this is what I'm talking about. Okay. Now, how do you, yeah, we want to find the volume. Okay. I think this can be viewed as a cone-like solid. The base is a triangle. Right. The base is a triangle. Here's a base, right? So base, this side is 12, and this side is 6. Right. So the area of the base is going to be the CDH is going to be, this is a right triangle. Half of 6 times 12, which is 36. Okay, so this is like a solid cone over the triangle. So the height, yeah, this is we call it maybe A, right? Don't be confused with the letter A. Okay, here. So the height of this cone is just equal to BC, right? Which is going to be 8. Yeah. So we remember the volume of a cone is going to be 1/3 of the base area times H. So 1/3, 36 times H. Okay, so now just multiply this out, right? And you will get 96. Right. Yeah, in general, if you have a cone, right? And so-called by definition, cone looks like that, okay? Connect all the sides. Cone. So if the height of the cone is going to be H, and the area of the base is A, then the volume of exhibit 1/3 A times H. And the base could be triangle, can be circular, can be, can be circle, okay, can be square, can be rectangle. Okay, let's do one more problem. Yeah, okay. So the last one, we're talking about tetrahedron, right? The last one is this tetrahedron consists of equilateral triangles. Okay, so it's going to be like that. How many pieces? One triangle at the bottom, and then like that, right? So consists of 1, 2, 3, 4 pieces. Okay, equilateral triangle with the edge length A. They all sizes A. Okay, find the volume and express it in terms of A. Okay. Now the tetrahedron can be viewed as a cone over the triangular base. So the volume, if the area of the equilateral triangle is going to be A, so A is going to be the base, let's go 3/4 A squared. That is the area of the equilateral triangle. Okay, so now you have to find the height. How to find the height? Okay, the foot point in the, yeah, you have to look at this. You have to look at the triangle. Okay, this is a triangle, vertical triangle. So you have to figure out what is the x here. And if you look at the x, that is x, right? Okay, this is a special triangle. Okay, so I think this is going to be half of A, right? Half of A over X is going to be square 3 over 2. You know why? That just be the special triangle. Just because this is 30 degrees. Okay. In other words, X is going to be 2 square of 3 here, A over 2, 2 to cancel out, A over square 3, okay? So that is X. So once you figure the X, you go back to the vertical triangle. This side is A, this side is X, right? So H square equals A square minus X square. Okay, so that's going to be A square minus A over square 3 square. So that is going to be after you combine, you have this. That is the H square. So you have to find the H. H is square root 2 over square root 3 and A. All right, so that is H. Then the volume is going to be 1/3 the base area times H. So 1/3 A is the square root 3 over 4 times A square. Now H is going to be square root 2 over square root 3 times A. All right. So square root 3 canceled out. What is left is the square root 2 over 12 and multiplied by A cubed. All right, so we're done with today's problem. You know, think about this, the tetrahedron. If you want to find the volume, you view it as like a cone over, we call it cone-like solid over the triangular base. The base is the equal-rated triangle, so you can easily find the area of the triangle. All you have to do is to find the height. In order to find the height, you need to apply the Pythagorean theory. You draw a addition line and you get a vertical right triangle is sitting there. Then you have to find the x, right? Now you want to find the x, you just focus on the base triangle. Yeah. And then you express the x in terms of A. Then you can apply, then you can use the vertical right triangle to find the h. Once you find h, express it in terms of A, then you can write down the formula for the volume. Okay. Okay, it's a little bit, yeah, geometry is a little bit challenging. You know, we go through all the formulas, Pythagorean theory, area comparisons. I hope you spend time to digest today's material when you receive my lecture notes, okay? And then go through all the problems by yourself before you do. Yeah, when you do the homework, it says homework is comprehensive, okay? But today's lectures is a focus on one topic, okay? So you should spend time to review the problems today here. Go over the problems we discussed today here. Maybe you find a simple solution. That's great. You can let me know, okay? Then you started to do homework, okay?